So, good evening, one and all. Myself, Yashvi Sheth, and today it is the 10th live session for the course Basic Principles and Calculations in Chemical Engineering. Which is taught by Professor Subrata Majumdar from IIT Guwahati. So, I will share my screen. So, let's start with the session. So far, in the lectures, we have talked about uh, basics, which is required in entire chemical engineering, basics of material balance, energy balance for steady state and unsteady state processes as well. So this all we have covered, and also if you need to solve any unit process or unit operation, then how you solve it. So we have talked about several unit operations as well, and how do you solve the equations, or how do you develop various relations and solve it. So moving forward with this course, this session is all about the mathematics, because in industries or in any even if you even if you are doing coursework, then you will encounter you will write the equations, material and energy balance equation, or any other form of equation, and you will have n number of equations that will be required to be solved. Okay, so for those equations, you you need some formulas which are very commonly used. So some engineering mathematical formulas are used, which you need to know. Also, there will be certain cases in which you will try to find out various correlations. Okay, so say for example, if you are developing a rate equation, just a second. For example, you are developing rate law. So any rate law is defined as minus dc by dt equals to k c raised to n. Okay, this is n is the order of reaction and k is the constant. Okay, so you try to do one experiment in which you will do what you will do. You try to measure like initial concentration, and you try to measure the change in concentration over the period of time. Here it is at t equals to 0, and this is at t equals to t. Okay, so with change in time, you measure the concentration, and from that you need to find out the values of k and n. So how do you do? You try to fit various models. Okay, so nowadays there is Excel and all. You use it very well. So in that case, what you do? You try to find out this k. So this k and n also. So these two are constants. And if you want to find out this, then if you solve it, then you might require Excel or any such uh, mathematical tool. So this is very simple equation. This can be even solved manually. But sometimes what you do, try to fit various, you have experimental data point, and you want to fit like whether it is a straight line fits or not, whether a straight line passes through it or not, whether it is a quadratic equation. So if a quadratic equation or exponential function, if it is there, so if it fits or not, then you need to have certain value or some constant which is known as r square, so that which will give you whether it fits or not. So say for example, this is my data point. Okay, so if I want to fit a linear line, then we can say that linear line fits this this data point. Now, if I want to fit an exponential function, then obviously you can say that exponential function does not fit this data points. So how do you know that whether any data point, whether any fit is fitting properly or not? So for that you check r square, and its value is usually 0 to 1, and more is the r square value, like as r square tends to 1, better is the fit. Okay, so you, for any correlation, you check the r square value. So this method is nothing but known as least square method, where you find out r square. So r square is nothing but known as regression coefficient, and it is the measure of goodness of the fit. Its value usually ranges between uh, sorry, square value usually ranges, as I said, it ranges between 0 and 1, and it is the like least square method is the method which is used to find the best value of the coefficients for any experimental data points. Okay, so if we are given with any data points, so say for example this is y, this is x, these all are data points, you need to find out whether a straight line fits or not. Now obviously the data points will not be the exactly same, it might be or it might not be exactly same, but we need to find one such line such that, like, this is the experimental y value and this is the fitted y value. Okay, so you need to find out, there will be certain error, okay, error between y fit. So there will be certain error, this is known as error. So there will be certain error between both these values, and there will be n number of data points for that. So what you do, you try to, now for a better fit, like if my how can you say that this line fits or not? So for that you need to have as much low error as possible, and this applies to every data point. Okay, so what you need to do, you need to have minimum error, and also you need to have cumulative error, because it applies at every data point. So cumulative or error should be minimum. Okay, now but this y exponential minus y fit, this error can be greater than 0 or it can be less than 0 as well, but error is error. Okay, say for example here there is this much error which is positive, this much negative error. Okay, so what will, if we simply add these errors, then it will nullify each other. Okay, so what does nullification means? Actually error is increasing, but this positive and negative sign will denote that error is getting nullified, so which is not the case, actual case. So what we do, we try to square the error. So y exponential y experimental minus y fit, we take the square of it, which is nothing but error ka square. So if since this squared term is always positive, then the summation of error will always be positive. Hence we can say that we need to minimize this sum of square of errors to find out whether the fit is good or not. Now you minimize this error square. Okay, and for that what you do, d by d x of error square equals to 0, because for at maxima or minima, d by d of any function will be 0. Okay, so you differentiate that and you equate it to 0. So now you can develop a correlation and you can find out. So y experimental will obviously a data point, and y fit will be nothing but um, just a second. And y fit is nothing but, let's say we need to fit a linear correlation, then it will be b naught plus b1x, say for example. Then you need to minimize this function, you need to square this, and you need to minimize this function to find out b0 and b1 values, which are nothing but said to be the best fit for this experimental data point. So likewise you can have another fits also. If you have this data point and if you want to check whether exponential function fits or not, then instead of this function you need to write exponential of x. Now it can be exponential x plus x or so. So any function you can write simply in this manner, and you need to minimize this overall function such that the error, the sum of square of errors is minimum, not 0, it is minimum. So by finding that way, you can know whether like you will be able to find out this constants, and you will be able to know whether the fit is good or not. Now moving forward, so as I said, you need to solve various equations. So you come across various equations which are non-algebraic. Okay, so like non-linear algebraic equations. Okay, so for linear equation you already know that if it is a1x plus b2y equals to c, a2x plus b1y b2y c2. So there can be n number of such equations, and if you want to solve, you already know that you usually write it in the form of a matrix. Okay, so ax equals to c, and this matrix, so you can find is A inverse C. Okay, so now there are for n number of such equations, there will be there are tools which you can use to solve this. Okay, so manually you can try to solve 3 or maximum 4 unknown variables. But if you have more than that, what you do, you try to use any softwares and you try to find out the values of this x, which is nothing but all the unknown variables. Okay. So now it is not necessary that you will always encounter with linear equations. So if you have non-linear equations, say for example exponential x minus x plus sin x equals to 0. So if you want to solve this equation, this is just a random equation that I have written as of for now. So if you want to solve such type of non-linear equation, like what is at what value of x you will get this function value equals to 0. So this is nothing but f of x. So you want to know at what value of x this function becomes 0. So for that, there are several methods, because this is just for linear equations. Okay, so for non-linear equation you need to have certain method, okay, by which you will be able to solve. Okay, so such methods are, because such this is nothing but a simple equation, and for industry, if you want to solve, then there will be n number of non-linear algebraic equation which are related with series of multiple or series of uh, units, unit operation or unit process. So to solve that, there are various methods. For example, Newton-Raphson, secant method, Regula-Falsi, graph, spreadsheet solution, etc. So these are amongst them. Newton-Raphson method is the most common one. Okay. So I will discuss Newton-Raphson in brief. So what is Newton-Raphson method? Say for example, you have uh, this is the curve, and it is nothing but y equals to f of x. Okay. So you need to find out at what value of x, this is y, this is x, this point you need to find out where f of x equals to 0. At what x f of x equals to 0. So you need to find out this value of x. Okay. So how will you find out? So what does Newton-Raphson do? It is nothing but it is derived from Taylor series expansion, from Taylor series expansion. Okay. So at this particular, so near this point, if you want to find out the function x, f of x, then what will it be? F of x will be nothing but x plus f dash x, x, this will be x1, x minus x1. Okay. x1 is the earlier previous point, plus f double dash x upon 2 factorial x minus x1 square. So and so on. This is nothing but the Taylor series expansion. Now if you ignore this higher order terms, because this delta is already small, and if you square it or even cube it, then after certain point of time, this all terms will be negligible. So you can restrict yourself till this point. So what will it be? F of x equals to x1 plus f dash x minus x1. So now if you solve this, and if you want, this will be nothing but f at x1, sorry. Okay. So if you want to find f, like at value of x at which if f of x equals to 0, then what you do, you this will be 0. So what remains is f x1 equals to x1 minus x f dash x. Okay. So x equals to x1 minus f of x1 upon f dash x1. Okay. So you can use such formula, which is nothing but known as Newton-Raphson method, and you can find out x2, which is nothing but x1 minus fx1 upon f dash x1. So you can find a new point. Say for example, this is x1. So you move this side. Okay. So you try to move this side and you find new x such that you are closer to the root. So this is an iterative method. Xn plus 1 equals to xn minus fxn upon f dash xn. So when do you stop? You usually stop when xn plus 1 minus xn is less than the permissible error. So there will be certain error, but there will be certain allowable value, difference value. So if it is less than that, then you can stop. So this was all about single variable. Now there can be multiple variables also. So in that case, how you do? Multiple variables. Then you solve it in the form of a matrix. So for single variable, it was x equals to xn plus 1 equals to xn minus f xn upon f dash xn. Okay. So multiple variable, you just need to write each of this term in the form of a matrix or in the form of an array. Okay. So this xn plus 1, if you have n number of unknown variables, say for example x1, x2 up to xn at n plus 1. So you write in such a way equals to x1, x2 up to xn at n minus. Now this is the derivative. Okay, derivative term. So for derivative term, this is a single equation for one variable. Now in the case of multiple variables, you will have a matrix, okay, which is nothing but known as Jacobi matrix. So you take the inverse of that Jacobi matrix at xn, okay, into f xn. So this is nothing but this xn is nothing but this vector, and this is xn plus 1. So you do vector addition and multiplication. So this will be a matrix and this will be a vector. So you need to do matrix multiplication. So this Jacobi matrix will be nothing but del f by del x, del f1 by del x1, del f2 by del x1, and so on, del f1 by del x2, del f2 by del x2, del f3 by del x, and because you have n functions which are related with x1 up to xn, so you need to have partial differential of each function with respect to each variable. So that will be nothing but a matrix. And for multiple variable to solve, to have a solution, you need to do prepare such matrix, and then you need to take the inverse. So by solving this, you will be able to get final answer. So manually it is very difficult to solve such complicated equations. So usually you can use MATLAB or so, okay, to solve such equations, because it is very difficult to solve this manually. It is very intensive in calculation. So now moving forward, uh, um, there will be cases where you need to solve integral equations. Okay. So there can be integral equation for one you will encounter for PFR when you will study PFR in CRE course. So this is nothing but a plug flow reactor. Okay. So for plug flow reactors, you usually have to solve integral equation. So all the time it is not possible to have algebraic solution of integral. Say for example, it is t, say for t1 to t2. You have one complicated sine t exponential t. x t raised to t power n dt. Here n is constant. Okay. So if you need to solve such equation, like this is one example, if you want to solve such complicated integral equation, then it is very difficult to solve, or it might be time taking also. So what you do, you have one method which is known as numerical integration. So so how do we try to solve numerical integration numerically instead of algebraic form? So what you do, you have certain function. Okay, this is f of x, this is x. So integration is nothing but area under the curve. Okay, so what you do, we try to divide this curve into smaller sections, and we try to find out the areas of each small section, and then we add up. Okay, so we try to divide this entire into small delta x, and delta x, if it tends to 0, then it can be dx also. So this is nothing but dx or dt. So you try to divide into smaller sections, and you try to find out the area of this section, and you add up. So there are various well-developed methods. So one is trapezoidal rule and another is Simpson's rule. So Simpson's rules also has Simpson's 1/3 rule and Simpson's 3/8 rule. So all these rules are based on certain assumptions, and each method has different assumption. Okay, so trapezoidal rule first. So starting with trapezoidal rule, does suppose this is the curve and you need to find out the integration. So what you do, to divide into section, and you assume that this is a trapezium or trapezoid. Okay, so you find out area of each of this and you sum it up. So I'm not going deep into the derivation of each, but you do divide in small sections and you consider this as trapezoid and you sum it up. So the final form of the integration I will be nothing but summation. So h, here you what you do, we divide into equal divisions. Okay, so delta x is common for all, so it will be h by 2 f. So if you, this is for this particular equation, a to b fx dx. For this equation, what will be the answer? F at a, which is the initial point, plus f at b, which is the final point. Okay, plus sorry, into intermediate points, f1x, f2x, So all these intermediate points are f1 to fn minus 1x. These are the terminal points. Okay. And what is h? H is nothing but b minus a upon n. So n is the number of points or number of divisions that you are doing. Now another is Simpson's rule. So 1/3 rule. So you consider try to form a parabola. Okay, first, second, third point. Try to construct a parabola and you find out the area of this parabola. Okay, this is one parabola, this is another parabola. So you're trying to find out the area under the curve of this parabola. So, and you later sum it up. So integration in that case would be nothing but h by 3 f of a plus f of b plus 4 into, now if you want to write it, then it will be summation I equals to 2 to n minus 2 fxi plus 2 into summation fxi I equals to 3 to n minus 1. Okay. So, for all the even terms, for easy remembering, for all the even terms, or just like for all the alternate even terms, this will be multiplied by 4 and rest terms will be multiplied by 2. It is mandatory that n is odd. Okay, so let's move forward. So now in this in the assignment of this week, we will implement all the formulas and we will try to solve various questions. So let's start with the assignment. Question 1. Single variable nonlinear equation can be solved by following. So I have given you the names of each. So spreadsheet solution, Newton's method, regular policy. So all of these can be used, okay, for solving nonlinear equation. Out of them, you can say that Newton's method is the most common one. So all of these is the correct answer. Now next question is, find out the root of the following equation. So here you are given fx equals to cos x minus x. Okay. So one of the best method is nothing but Newton-Raphson method. So we will try to use Newton-Raphson method to solve this formula. Okay. So here you are given fx equals to cos x minus x. So if you want to find out f dash x, which is nothing but d dx of f of x. So applying differentiation for the function on left and right side, it will be nothing but d dx of cos x minus x. So this will be nothing but d dx cos x minus d dx x. So differentiation of cos x is nothing but minus sin x, and again differentiation of d dx x is 1. So into 1 minus d dx x is 1. So f dash x is equal to minus sin x minus 1. So now if you apply Newton-Raphson method, so xn plus 1 equals to xn minus f of x upon f dash x. So you put up the values. So xn plus 1 equals to xn minus fx equals to cos x minus x upon f dash x is minus sin x minus 1. So you can take out this minus common. So it will be xn plus cos x minus x upon sin x plus 1. So now this is the general for, okay. And so to start with, you are given as x naught is given as 1. So if you, so for the first time you put x1 equals to x naught plus, this will be 1 x, okay, cos 1 minus, so this 1 will be in radian, okay, so take care of that. So if you are trying to solve such equations, then sine and cos, if you have a numeric digit, then always take that in the form of radian, not in degree. Cos x minus x, x is 1 upon sine 1 plus 1. Okay. So if you do first calculation, so it will be cos 1 minus 1 divided by sine 1 plus 1. Okay. So 1 plus so it first point will be 0.75, 0.75. So now what you will do, you will take this value and you will again put up x2 equals to what will be it? x1 plus cos x1 minus x1 upon sin x1 plus 1. So if you again put up the value, what will it come? So cos 0.75 minus 0.75 divided by sine 0.75 plus 1. Okay, so 0.75 plus answer is nothing but 0.739. Okay, so you can see that the difference between both these values is still less. Now if you again want to check whether this is the correct, like whether it is further changing or not, you again put up, you do, it will be, wait. Again, x3 will be x2 plus cos x2 minus x2 upon sin x2 plus 1. Okay, so again you put up point x2 is 0.739. Okay, and you find out the correct answer. So it will come out to be again 0.739. So as you can see, the difference between x3 and x2 is nothing but 0. Okay, so there will be a number of digits after 9 also, but you can neglect that and you can say that the difference between them is nothing but almost equivalent to 0. So the correct answer for this is 0.739. Okay, so this is the correct answer. Now let's move forward. So now you need to find out the integral value of the equation given below. So the equation is nothing but y equals to integral 0 to 3 x fx dx. Now you are given with x and fx. Okay, so you need to do now, because you do not know what is fx, so you need to use either Simpson's method or trapezoidal method, because we will get, but we know the value of x and fx. So we can use numerical integration to solve. Okay. So here let's start with trapezoidal rule because it is very simple. So if you want to apply trapezoidal method, so let's first make the column, because what is trapezoidal rule? Integration, it will be nothing but h by 2 f at y at 0 plus y at 3 plus 2 times y, like summation yi's. Okay. So if you want to do such thing, you will have to make one table. So for all the values of f and fx, you need to find out x into f of x. So let's make that table. So you will get one value of x into fx. Okay. So here it will be 0, then 0.5 into 1.94 is nothing but 0.97. This will be nothing but 1.78. 1.5 into 1.5 is nothing but 2.25. Then 2 into 1.11 is nothing but 2.22. 2.5 times 0.61 is nothing but 1.525. This will be 0. So if you want to find out the integral value, then let's put up the value. Now here what is h? H is b minus a over n. So b is given you as 3 minus 0 upon n. What is n? N is the number of data points. So it is 1, 2, 3, 4, 5, 6, 7. Okay. So it is 7. 3 by 7. Or what you can do? You can directly take the difference of both. Okay. So that is also h. So 3 by 7 into 2, because it is h by 2, into if like this is y0, y1, y2, y3, y4, y5 and y6. Okay. So it will be y0 plus y6 plus 2 into y1 plus up to y5. So if you solve this, if you put up the values and solve this, it will come out to be 3.74. So for this question, 3.74 is the correct answer. Okay. Now let's move for the next question. Calculate integration 0 to 1 x square dx. Here you are given n equals to 4. Okay. So what is trapezoidal rule? Let's find out h first. H is because you need to, here in this question, the table was given to you. Now here you will need to prepare the table on your own. Okay. So the function here given is f(x) equals to x square. So h is nothing but 1 minus 0 upon n is given to you as 4. So 1 by 4 is nothing but 0.25. So how will you prepare the table? So for each x, so you will need to find out x and fx equals to x square. So x, how will you do the increment of x? So you need to start from initial value 0. So this is 0 and you do 0 square, which is 0. Now the next data point will be 0 plus 0.25 because there is the difference of 0.25 between each x. Okay. So what you do is 0 plus 0.25, it is nothing but 0.25, and you take the square of 0.25, which will come out to be 0.0625. So next point will be 0.5. So 0.5 square is nothing but 0.25. Then there will be, if you add again, it will be 0.75. So 0.75 square is nothing but 0.5625. And next is, obviously it will be 1. So 1 square is 1. So you can see that we have developed a table. Now let's say this is y1, y2, or you can say f1, f2 also, y3, y4, y5. Okay, so how will you do? Trapezoidal rule apply. So it will be nothing but I equals to 0.25 by 2, y1, 0 plus y5, 1, plus 2 into y2 plus y3 plus y4, it will be 0.0625 plus 0.25 plus 0.5625. Okay. So if you solve this, here you are given in the form of fraction. So if you solve this, it will come out to be, the fraction will be nothing but 11 by 32. So this is how you do. You can calculate on your own the value and it will come out to be 11 by 32. Next question is, use the trapezoidal rule to calculate integration 1 to 2 1 by x dx. So here you can say fx is nothing but 1 by x. Okay. So you need to prepare a table of x and 1 by x. So for what all increments you need to take into account? So for that, what you will do? You will find out h is 2 minus 1 upon 2 because n you are given as 2. So it will be nothing but 1 by 2. It is 0.5. So you start with 1. You take the increment of 0.5. So this will be 3 by 2 equals to 1.5, and next will be 2 because there is only one data point in between. Okay, so there are two subintervals. So now you take 1 by x of each. So 1 by 1 is nothing but 1. 1 by 0.5 is nothing but it will be 2 by 3. And 1 by 2 is nothing but, this will be 1 by 2. So if you apply trapezoidal rule, what will it come out? It will be h is nothing but 1 by 2 into 2 because h by 2 you need to do into 1 plus half plus 2 into 2 by 3. So 1 by 4, the LCM will be 6. So 6 plus this will be 3. So 6 plus 3 is 9. 9 plus 2 is 11. So it will be 11 by 24. So there is no correct option match here. So the correct answer for this question is 11 by 24. So you can check and correct You can even correct in the way, like you can cross check. For example, if 11 by 24 is 0.458, and you can numerically algebraically solve also. For example, 1 by x is nothing but ln x. So ln x at from 1 to 2. So it will be ln 2 minus ln 1. So you can solve this, and you will be able to calculate. Sorry, this will not be 11 by 24. This will be, this is already 4 over here. Okay, so 4 into 2. So it will be 8. Okay, so 6 plus 8 plus 3, it will be 17. So answer is 17 by 24. Sorry for the mistake. So correct answer is 17 by 24. Next question you are given is a function f of x is given as the table of values. You need to approximate the area under the curve y equals to fx from x equals to minus 4 to x equals to 8 using Simpson's rule with n equals to 6 sub intervals. Okay. So let's do that. So here you are directly given the table. So what you will do, integration will be nothing but h. So h is given as like minus 2 minus 4. So it is nothing but 2. So 2 is the difference. You can see difference is 2. 2 by 3. Initial point f1. So this is 1 plus end point. So you just need, for every case, you need to add terminal plus 4 into this. Let's say this is f1, 2, 3, 4, 5, 6, 7. So all the even intervals you need to multiply with 4. So it will be 3 plus 4 plus 9 plus 2 into this will be 4 and 6 odds. Okay, so 4 plus 6. Now if you solve this, the answer will be 66. You can try it on your own. The answer will come out to you as 66. Now the total number of ordinates present must be dash for Simpson's rule. So as I had mentioned that there should be n terms and that n has to be an odd number. So for an odd number always you can apply Simpson's rule. Otherwise it will not be applicable. Which of the following indicates the assumption assumed in the trapezoidal rule? So it is nothing but mid area is the mean of end area. Next question you are given as solve integration 8 to 15 ln x dx. So here fx is ln x, okay, and 2n you are given as 10. So n is nothing but 5. So let's do that. So n is 5. So if you want to find out what is the difference between two points, So what you will do, h equals to b minus a over n. So 15 minus 8 upon 5, it will come out to be 1.4. So if you apply now the Simpson's rule, so I have already calculated, wait, uh, based on this h value, I have already calculated the value of x and ln x for you. So the difference between 2x is nothing but 9.4 minus 8. So it is for all, it is 1.4. And for each of the x values, I have calculated ln x. So now if you apply Simpson's rule, so what will be the integration formula? It will be nothing but h is 1.4 divided by 3 into f1x. So it will be 2.07 plus fn. So last term you add as it is plus 4 into to alternate. Okay, so start from here and alternate. 2.24 plus 2.5 plus 2 into 2.37 plus 2.61. Okay, so if you solve this, the answer will be nothing but 16.98. You can cross check and see later. So next question you are given as integration. You need to find out integration 1 to 3 exponential x square dx. So one way is you can try to simplify this equation. Another, here you are asked to solve it with Simpson's 1/3 rule. Okay, so you are given n as 8. So for even number of terms, you cannot apply Simpson's rule. So let's do it with trapezoidal rule. Let's first find out h. H is nothing but 3 minus 1 upon 8. Okay, so it will be 2 by 8. Now for this value of h, I have prepared x value, x square, and x exponential of x square. So I have prepared all the x, return x square, and exponential of x square. So to apply, to find out the integration, what you will do, h by 2, we will apply trapezoidal rule here. The difference between trapezoidal rule or Simpson's 1/3 rule is nothing but the accuracy. Okay, so any rule you apply, the answer will be more or less same, but more accurate will be Simpson's 1/3 rule. But however, the answer will be in same, like on an average, it will be same. So it will be f1. So f1 is nothing but 2.7 plus 8103.08 plus 2 into all the rest values, 4.77 plus up to 1924.65. So if you solve this, the answer will turn out to be 1475.43. So you can solve it on your own. The answer should be 1475.4. Next question is, Simpson's rule is exact if real function is dash or dash in nature. So I have already told you that Simpson's rule, so for that we use parabola to find the area. So parabola has the equation of x square y or y square x of that kind, which has order of cube. So okay, so for any equation of cubic nature or parabolic nature, it should give me exact solution. So Simpson's rule will give me exact if real function is parabolic or cubic. Next question is, if Newton's method fails to converge, it will result as, so it will oscillate, because it will oscillate means it will give you a value within that range, and so if you again reiterate within that range, so answer will be in that particular range only. So it will oscillate between two values. Next question is, if the rank of the matrix is equal to the number of variables, then, so what does rank of a matrix? So this is nothing but the way you solve any linear equation. So you convert it into the form of a matrix and you solve. So how do you do that? So rank of matrix is nothing but, so all the equations all the equations you write it in the form of a matrix, here rows. So rank represents number of independent or columns. Okay, so for number of independent rows and columns, what you if this number of independent rows and columns, so you relate it with the right hand side. Okay, so if it is equal to the number of variables, so you will have three equations, three variables or three unknowns. So you can solve like each independent equation, so you will have unique solution. Otherwise there can be infinitely like if there are like if you have 2x plus y equals to 3 and 2x plus y equals to 5. So in this case, these two equations are related to each other. So you can say that this will have infinite number of solution. Okay, so you can put any value of x and you will get n number of y. So you can say that you will have infinite number of solution. Or there are chances that no solution also occurs. But for this particular case, because you have n independent like independent rows or columns has same number of variables, so you can say that unique solution will be there for the set of equation. Now water is flowing through a pipeline 6 centimeter in diameter. The local velocities at various radial positions are given below. Estimate the average velocity using trapezoidal rule. So integral is nothing but average velocity, and its formula is 2 by r square. R square is diameter ka square. So you are given with the diameter. So r will be nothing but 3 centimeter, 0 to r, ur, dr. So this is a constant term. Okay, so you can multiply, you can first find out this integral, and later you whatever value you get, let's say it is I, so you multiply by 2 by r square to find out u bar. So let's first find out this value. So for that what you need u into r. Okay, so this is the function f of r. So what you will do, you have u value, you have r value. So you make a table of u into r. So you can make the table of u into r. I guess the values are similar to the ones which we had in previous question. So you can see here. Yeah, so you can see that the values are same. So the integration value in that question was coming out as 3.74. So here you know that 0 to r, u into r into dr is nothing but 3.74. So u bar will be, so you can again cross check, you can calculate on your own. 2 by r is 3, so 3 square into 3.74. And if you do the calculation, the u bar will come out to be 0.832. Moving forward, choose the correct statement for Simpson's rule for numerical integration. So you can look into the options. So it is applicable only for n odd number of data points. So obviously that is correct. So we apply only for odd number of data points. The data point should be at an equal distance. Yeah, obviously, because otherwise, what we do during the derivation, we take out that delta x common. Okay, so that is how h comes out, and delta x will only come out when uh, you have equal delta x. Otherwise, what will happen if delta x is unequal? Then this solution will be tedious. So we make sure that the delta x is common, or the data points are at equal distance. So this is also correct. And obviously this is more accurate as compared to trapezoidal's rules. This I had already mentioned. So all these statements are correct for this question. Next question is, for Newton's method for solving the nonlinear equation, you are given with two statements and you need to check whether these statements are correct or not. So Jacobi matrix and its inversion has to be calculated for each iteration. So for multiple variables, I had said that xn plus 1 equals to xn minus j inverse xn into f xn. So this you need to do, and you need to do at every data point. So you need to calculate j inverse at every data point, and this is iterative procedure. So obviously this is correct because you need to calculate at each step or at each iteration. Now second statement, so first statement is correct. Second statement says that it always converges. Now it is not necessary that it will always converge because it depends on the initial guess also. So this is not always true. So second statement is not correct because always cannot be there. So sorry, the correct answer is option D. Statement 1 is correct, statement 2 is incorrect. Next question is, determine the root of the equation x equals to e raised to minus x using Newton's method, and take the initial guess as x equals to 0.2. Perform 3 iterations. So let's derive first the iterative formula. So what you will do, x equals to e raised to minus x. So what is fx? Fx is nothing but x minus e raised to minus x, and you need to equate it to 0. So you need f dash x also for Newton's method. So f dash x is nothing but x minus d dx e raised to minus x, which is nothing but 1 minus d dx minus e raised to minus s. Derivative of exponential is nothing but itself, minus x into d dx minus x, it will be minus 1. So this will be 1 plus e raised to minus x. So if you write down the formula, what it will be, xn plus 1 equals to xn minus fx equals to x minus e raised to minus x upon 1 plus e raised to minus x. This is nothing but f dash x. So you need to start with x naught equals to 0.2. So if you write 0.2, so x1 equals to x naught is 0.2 minus 0.2 minus exponential 0.2, like minus 0.2 upon 1 plus exponential minus 0.2. Okay. So this will come out to be 0.54. Now again for second iteration, you substitute this value. So x1 minus e raised to minus x1 on 1 plus e raised to minus x1. So if you substitute and you perform again next two iterations, just a second. So you do two more successive calculations. So again you need to terminate when x3. So x3 will be x2 minus x2 minus x2 minus x2 upon 1 plus e raised to minus x2. So if you substitute the values and if you do further two more iterations, answer will come out to be 0.56714. So A is the correct answer. You can cross check and do it on your own. Let's move forward. So the table of values gives a function fx. Now approximate the area under the curve y between x equals to 0 to x equals to 4 using Simpson's rule. So what you will do, Simpson's formula has h by 3 fa plus f of b plus 4 into these two values. So let's say it is even 2 into odds. Okay. If you substitute the value, so what is h here? H is nothing but you have difference of 1 between each. Okay, so you do not always need to calculate what is the value of n. You will do 4 or 4 by 4. So subdivision is 4. So 4 by 4. So you always do not need to do this. You can directly know what is h by taking the difference between 2. Okay, so this is nothing but h. So this is 1 by 3. If A is 2 plus FB is 5 plus 4 into these two values 7 and 10. 7 plus 10, 2 into 12. So if you solve, it will come out to be 33. Correct answer is 33. Next question is the concept of least square method is dash. So I have already explained in the beginning of this class. So what is least square method? So it is nothing but what you do, you find out the errors, and I have even told you why, like what you do, you take the sum of the square of errors and you minimize that function so that you will be able to find the values of the constant in the empirical formula. So what you do, minimize the sum of the square of errors. And why you do? Because if you simply add the errors, what it might nullify each other. On the other, however, it is not the truth, because error can never be nullified if there are two different data points and they have opposite errors. So that can never be nullified. So what you do, you take the square so that you can always get, you will is positive error and you can sum it up. So the correct answer is minimizing the sum of the square of errors. So that's all from my side today. This is the end of the assignment, 10th assignment. So yeah, I can stop here today. So thank you everyone. Thank you for listening. Thank you for joining.